Question number 5, it says let U is Bernoulli 0.2 and V is Bernoulli 0.5 and W is Bernoulli 0.8 and all U, V and W are independent. Okay. Now we have defined X to be maximum of U, V and W and Y to be minimum of U, V and W. So okay, so the first question that we have here is find the range of X and Y. So what is X? So X is your maximum of U, V and W. And what is Y? Y is minimum of U, V and W. So as each of the U, V and W are Bernoulli random variables, so each of them will take the value in 0, 1. So U will take the value in 0, 1. V will take the value in 0, 1 and W will take the value in 0, 1. So even if you take the maximum of U, V and W, so if each of the U, V and W is taking the value 0, we can have X to be, X will take the value 0. If one of the U, V, W is going to take the value 0 and the other is others are 1, so in that case maximum will come out to be 1. And similarly if each of the U, V and W are going to take the value 1, so again the range the maximum is going to take the value 1. So the range of X is 0, 1. Similarly in case of Y, each of the U, V and W is going to take the value 0 and 1, and if each of U, V and W is taking the value 0, then minimum is 0 of course. But if any one of them is going to take the value 0, then again the minimum will be 1. So in that case, in every case except when all the U, V and W are going to take the value 1, only in that case the minimum is going to be 1 and in other cases it is going to take the value 0. So again the range is 0, 1. So we can say that the range of X and Y, so Tx equals Ty equals 0, 1. So this is your answer. Okay. So the second part of that question is find the probability that X equals 0. So X equals 0 means what? X is maximum of U, V and W. And we are saying we have to find out what is the probability that maximum is 0. So maximum can be 0 only if each of the U, V and W are going to be 0. So U equals 0, V equals 0 and W equals 0. And since it is given that U, V and W are independent, so in such cases we can write that this is equals to probability U equals 0 into probability V equals 0 into probability W equals 0. So since U was Bernoulli 0.2, V was Bernoulli 0.5 and W was Bernoulli 0.8. So probability that U is going to take the value 0 is going to be 0.8. Probability that V equals 0 is going to take the value 0.5 and W equals 0 is going to take the value 0.2. So this is going to be 0.08. So this is your answer. Now the third part of the question is find P x equals 1. So as we so we have to find probability x equals 1. So we know that the range of x, P of x is 0, 1. We have already found in the previous question that probability x equals 0 is 0.08. And since x is taking just two values 0, 1, so probability that x will take the value 1 is going to be 1 minus probability that x equals 0. This is 1 minus 0.08. So this is going to be 0.92. So this is your answer. Now the fourth part of this question is find probability y equals 1. So what is y? Y is minimum of u, v and w, right? And we have to find this equals 1. So in what case the minimum is going to be 1? It will happen only if all u, v and w, so all u, v and w is equal to 1. So u equals 1, v equals 1 and w equals 1. And since they all are independent, we can write probability u equals 1 into probability v equals 1 into probability w equals 1. So, probability u equals 1 was equal to 0.2. So this is going to be 0.8. So this is going to be 0.2. This is 0.5 and this is 0.8. So again, this is going to be 0.02. Sorry, 0.08. Similarly, probability y equals 0. This is going to be 1 minus probability y equals 1, since the range of y was 0 comma 1. So probability y equals 1 we have already found in the previous question. So that was 0.08. So again this is going to be 0.92. So question number 6 is, let x and y be two independent geometric P. Assume that z equals x minus y. Now you have to find the value of fz of k, where k is a natural number. So what is given to you is x and y, they are independent and they are geometric P, right? Now you have to take z equals x minus y. So what is the value of fz of k, where k is a natural number, right? So fz of k equals what? This is probability that z equals k. And what is z? Z equals x minus y equals k, right? Let's say I fix y to be equal to I. So if you fix y to be I, so x you can write it as I plus k and y you can write as I. So you know that x and y are geometric P. So their ranges will vary from 1 to up to infinity, right? So y will vary from 1 to infinity. Now it is also given that x and y are independent. So this we can write it as y equals 1 to infinity, probability x equals I plus k into probability y equals I. So just use the formula now. So this is y equals 1 to infinity. What is probability x equals I plus k? It means at I plus k success, at I plus k trial you have the first success, right? So this you are going to write it as 1 minus p to the power I plus k minus 1 into p. Similarly, at ith trial you have the first success for the random variable y. So this you will write it as 1 minus p to the power I minus 1 into p. So this is going to be p square sum over 1 minus p I plus k minus 1 plus I minus 1, where y will vary from 1 to infinity. Sorry, this is I, this is I, this is I, and this is I. Okay. So this you can write it as p square I varying from 1 to infinity, 1 minus p 2y plus k minus 2. So we can take 1 minus p to the power k minus 2 to be outside. So this we can write it as p square 1 minus p to the power k minus 2, sum it over 1 minus p to the power 2i, I is varying from 1 to infinity. Now this is a geometric series, so we can use the formula of geometric series, and so if you solve it you will get p square 1 minus p to the power p to the power k minus 2, and this is going to be 1 minus p to the power 2 plus 1 minus p to the power 4 plus 1 minus p to the power 6 up to so on. So you can take 1 minus p square to be common, so it will be p square 1 minus p k minus 2 1 minus p square, right? This is 1 plus 1 minus p square plus up to so on. Now you can use the geometric series formula, the sum of the infinite geometric series, and this is the formula is a upon 1 minus r. So in this case, r a is 1 and r is 1 minus p whole square. So if you use the formula, you will get p square 1 minus p to the power k minus 2. So you see, like 1 minus p square and 1 minus p minus 2, they will get cancelled out and we'll just have 1 minus p to the power k. And this is going to be 1 upon 1 minus p whole square, a upon 1 minus r, right? Now if you solve the denominator part here, you will get 1 minus 1 plus p square minus 2p. So this is nothing but p square, sorry, this is 2p minus p square. So the final answer that you will get is p square into 1 minus p to the power k divided by 2p minus p square. So we can cancel the p term here and you will get p times 1 minus p to the power k divided by p minus, sorry, 2 minus p. So this is going to be a final answer, and this is fz of k. So as you keep substituting different values of k here, you will get your probability distribution. So question number 7 is, suppose that the number of people who visit a dance academy each day is a Poisson random variable with mean lambda. Okay. Now suppose further that each person who visits is independently female with probability p or male with probability 1 minus p. Now you have to find the joint probability that exactly m men and w women visit the dance academy on any particular day. So let us define a few random variable here. So let's say your x denote the number of women who visit the dance academy on any particular day, and let's y denote the number of men who visit the dance academy on any particular day. So, and the probability of this is p and the probability of this is 1 minus p. What we have to find is, let us denote another random variable z that is equal to x plus y. So this denotes the total number of people who visit a dance academy each day. So it is given here that the number of people who visit a dance academy each day is a Poisson random variable with mean lambda. So this is going to be a Poisson random variable with the parameter lambda, because we know that in case of a Poisson random variable, the mean and variance is equal to the parameter of the distribution. So here z is going to be Poisson lambda. Now we have to find the probability that x equals w, comma y equals m. Now if you condition this on z as in total number of people who visited dance academy. So if you condition this on z, and if this z is not equals to, if z is not equals to w plus m, if it means that the total number of people who visited the dance academy is not equal to w plus m, then in that case the probability that probability that x equals w and y equals m given z equals to some z is going to be 0. So we can just take probability z equals we can just condition on z equals w plus m. So this we can write it as probability that x equals w, y equals m, given z equals w plus m, into probability that z equals w plus m. So z is a Poisson lambda random variable. So this we can write it as e to the power minus lambda, lambda to the power w plus m by w plus m factorial. Now what is x equal w comma y equals m given z equal m plus w plus m? So the total number of people who have visited the dance academy is given to be w plus m. So what is the probability that number of women is w? So in a way, this is modeling your binomial random variable. This models your binomial random variable with w plus m people who are visiting the dance academy. And if I am considering number of people, number of women who are visiting the dance academy as success, then in that case, this term here models the binomial random variable with n, with the parameter n equals w plus m, and probability p, because probability that so because it is given that the person who visit the dance academy is a female is probability p. So I can take the parameter as w plus m comma p. Now if you solve this, so we can write this as n choose x. So in this case, n is w plus m, n choose x. So x is what x is w here. So n choose x, p to the power x. So p to the power w, and 1 minus p to the power w plus m minus w, that is m. Sorry. So if the people who are visiting the dance academy as a women is a success, in that case this term here models the binomial distribution with the parameters w plus m comma p, and we can write this as this term. Now if you multiply this with e to the power minus lambda, lambda to the power w plus m by w plus m factorial, now just solve this, you will get w plus m factorial divided by w plus m minus w factorial into w factorial, p to the power w, 1 minus p to the power m, e to the power minus lambda, lambda to the power w plus m divided by w plus m factorial. So this will get cancelled out, and here you will have, so this is again will get cancelled out, and you will have um, p to the power w, 1 minus p to the power m divided by m factorial w factorial, e to the power minus lambda, lambda to the power w plus m, lambda to the power w plus m. So our final answer is p to the power w, 1 minus p to the power m, e to the power minus lambda, lambda to the power w plus m by m factorial w factorial. So this is your answer. Thank you.